expressions here on this one. So yesterday we talked about creating like terms and using the distributed property and creating equivalent expressions. So today we're going to build on that with adding linear expressions. So when we talk about some key vocabulary, we talk about linear, we mean a word named a line. It's an expression where the variable is to the first power is really what linear means, but that's the idea. And then we have a nonlinear expression, which is just a non-line, would make it create a curve. So let's take a look at our next one. All right. Make sure I'm clear and then we take a look at it. All right, so our first side, this is a linear expression because I have, let me switch colors to a different color, a little brighter color we can see. We have a 2x plus 3. This is going to be one number. So we're really adding like this. So if you think about it, what we're doing is we're saying, okay, we're doing a problem like 34 plus 13. Because I could split that out to 30 plus 4 and 10 plus 3. And I still add them together to get the final answer. That's really what I do. I would add place values at a time. I'm doing very similar things here, except my place values, instead of being place values, I have x terms being added with x terms. So I'm going to use my commutative and my associative property to regroup and change the order and say, okay, 2x plus x. Okay, together that makes 3x because I have a hidden 1 sitting right there. I'm going to come over here and go, okay, plus 3 plus 4. So 3 and 4. That's 7, and it's a positive 7, so I'm going to say it's a plus 7. Just like I came over here and did my problem. Just like I would have put 30 and 10 together to get 40, plus 7, and I would have put them together to get 47. Here, because they're not the same, I can't put them together. Here, same here. Don't want to leave it like this, but I can't simplify this any further. All right, go ahead and pause the video and give this one a try. Okay, now this one became a little trickier, because you got to change up your thinking a little bit. You got to think this is really your negative number. And this is really a negative number. That you've got 2x plus x. So I still get that same 3x from the previous problem. But now I'm going to have negative 1 plus negative 5. And I'm going to get a negative 6. So instead of writing plus a negative 6, I'm just going to write minus 6 because that means the same thing. This is the most important shift we have to make today, is when I see a minus sign, it's no longer not subtraction. It is a negative number. And that's really the key to becoming really proficient within the integer number system, is to set that up. I could do keep change op on each of these and recreate it, but it becomes easier just to think, oh, that's a negative 1. Because if I did keep change op, 2x plus the opposite of 1 is negative 1. And it's the same idea. All right, let's try some of these two. All right, pause the video and see what you can come up with these two problems. All right, so let's say 6x plus x, that's 7x. 2 plus a negative 3, that's a negative 1. There's my first answer, good job. Same here, 4x plus x, that's 5x. This time I've got a negative 2 plus a negative 4. Gives me a negative 6. There are my two answers. All right, let's see what else we can do. Now we're going to skip the models on this because we understand our negative rules. Now I've got a negative x term. It doesn't really super change what we've been doing, but it does. It's the first time we've seen it. So we're going to go 2x plus a negative x. So what's a negative x? Well, it's really a negative 1. So I'm going to say 2x minus x minus 1 is just x. Negative 3 plus a positive 4. That gives me a positive 1 using my integer rules. All right, it's your turn to give this one a try. Don't worry about the models. Again, if we didn't know our integer rules, we would definitely keep that in mind. All right, so you set it up as 3x plus a negative 2x to get positive x once more. I don't know why I put a line there, we'll make it positive x. And negative 6 plus 7, which gives me another positive 1. There's my answer. It's as simplified as it can get. All right, last one we're going to try. Now this one's a little trickier because now I have something new involved. I have a distributed property. I'm going to bring the previous lesson into today's lesson. I have a number outside of a number set, so I'm going to multiply or distribute to both of these. I'm going to say it's 2x plus 6, that's my new number, plus 3x plus 1. Because I would go through my order of operations and do my multiply and divide before I do my add and subtract. So now that I've got it simplified into an simple expression, I'm going to say 2 plus 3 is 5x, and 1 plus 6 is 7, being my final answer, 5x plus 7. All right, it's your turn to give one a try. Pause the video and see what you come up with. All right, so the first thing you did was distribute to get 4x plus 4 plus 5x plus 2. And now you're going to add your like terms, 9x plus 6. And the reason it's positive 6 is because we have two positive numbers. All right, last time, what if I've got a negative? Well, I've got to keep that in mind. I've got 5x, and that's really a negative 4, so now it's a negative 20 plus 2x minus 7. So I'm going to follow my rules again. 5x plus 2x is 7x. Negative 20 and negative 7 is a negative 27. All right, so you've gotten a chance to kind of practice all these. All right, last time you're going to practice on your own, and then you'll be all set. All right, so together you should have gotten 7x minus 29, been your final answer. All right, so we've got a really good handle on how we do this. All right, your job is, if you have any questions, to do your homework. If you have any questions, please come ask me. I'd be happy to help.